duty. Okay. Oh gosh. York. Yes, and Matt. Oh, somebody sound check me.
Did we have a topic this week, or are we picking up where we left off last time with how do you know your corpus is actually representative?
I can go any which way you like. Let me do my my legal spiel here, and then we can take off. I'm still actually here. People are piling in. So maybe it's slowed down here. Yeah, okay, so, oh, and the chat's on, and there's Zen too. Okay, hang on.
Hello, guys.
No audio reconnecting. Oh, fine. Okay, fine. We had technical fail. Somebody's retrying. It's all good. I guess I am recording now. Here's Keith again, trying again. So this is Coffee Compiler Club. Anything to do with, it's been recorded live. It shows up on Twitter within a couple hours to a day. Anything to do with compilers and language runtimes and typing systems and garbage collection, concurrency and pointer chasing and memory bandwidth and performance. And I don't know what else, all fair game. I ask you mute your mic if you're not talking, just to keep the background noise down. It's an open mic, say what you want. My goal is to have a fun conversation and learn something every week, and it's not to drive the conversation, which I sometimes do. And Cameron especially knows this and is happy to whack me on the head when I'm out of line. So it's all good. Keith is having failing issues, so we're going to get started while he's still joining, because who knows how long it takes. And then, Twitter and Zen asked me to peruse a paper, and I said things on Twitter like there's some factual errors, and then the Twitter folks said, hey. So I'm happy to talk about that. Somebody here said, hey, let's go talk about the corpus of. Why don't we do that? I think we have a quorum to start on the corpus of when do you have enough test cases kind of thing. I think that was what the question was. This is a continuation of last week's what you said. I don't remember who said it. And then we'll rotate to the paper if we get more people in here who are interested in the paper. Because I don't know who online was excited about talking about the paper, but I want to give them a chance to pile in. So what were you thinking about from last week with what was your question? Who said it? What was your question?
I don't remember who asked it last week. The question was roughly, over time, the way people use your language can change. How do you know whether your corpus of tests, like whether an optimization is good or bad, depends on what the universe of programs looks like?
Oh, yeah. Well, up until this happened to Hotspot, I'd have said it was done within a couple of years of widespread use. But then Hotspot, saw the giant rotation and.
Certainly, as the highly dynamic languages piled in on the JVM, it changed the corpus.
Oh, link to the paper. Yeah, I have it. I have it in my PDF. I have it online. Give me a second. Somebody else can say something. I'm looking up a paper. I should throw in the link here. I even have the PDF open. Oh, maybe. Oh, there you go. Yes, thank you. Is that the one? Yeah, it's got to be the one. Yeah, that's the one.
Matt's getting slow.
So yeah, I don't know when you just keep adding as you go. I think the lesson for me there was the set of excited users using the language rotated. It got big, and there was a centroid of people coding from, 90s, 2000s era computing as the normal from that era. And then all the new dynamic languages showed up, and the corpus like rotated off to the side, and the test cases didn't follow. And a lot of the test cases are, performance. So you don't do the performance tracking, you don't see, and you think in the beginning it's all, it's all weird corner cases that we were never intended to sort. Well, we still never intended to sort on it, but people were excited to use it. So what can you do? And then go after it that way. We might have, oh wait, no, Keith might be finally in, maybe. Keith, did you make it? Maybe. Third time around.
Yeah, third time's a charm.
This reminds me a bit of one example which doesn't even require dynamic languages to display a severe performance difference. A while ago, people were like trying to fix Scala collections, which is like another statically compiled language for JVM. And it turned out that from the proof of concept code, which had like almost no inheritance involved, to integrating like the new implementations into the overall collection framework, there was like a huge performance hit, because it turns out like having 30 superclasses has impacts on performance, or 30 interfaces or something. But yeah, this was, I think, quite surprising, because nobody expected it. And it's like, yeah, most people didn't expect it, but if they expected it, they assumed that it was common enough that the JVM was optimizing it, and it turned out it simply didn't.
Okay.
I believe that you need more aggressive inlining for the collections to work for the Scala.
Yeah, you have a huge amount of forwarding methods, and at a certain number, it simply gives up. The JVM throws the hands up and says, no, good luck.
And those were heuristics that, I don't know where they're at now, but I threw something in 30 years ago because people would hand us corner cases to test the compiler that would just break it. Like, here's an infinite, hand unrolled, machine unrolled recursive calls, right? 1,000 layers deep, right? Well, you ran out of some resource, and you threw it out of bounds, or you threw it out of memory, or you threw it whatever, and you died. So that was obviously, junk machine generated code to break you. So you just put a cap on it. No one inlines more than 20 layers, so be done. You say you got 30 layers of inlining, and I have a cap at 20, and you're done. It doesn't inline. And so, I think the cap was actually 10 for a very long time, and I don't know where it is now. It was, if you were just doing accessors, there was no limit. But if you did any trivial thing, like the bytecode, literally the bytecode pattern match did not pattern match a trivial accessor, it counted. And when you hit 10, we stopped. And, you can argue good or bad. It was the right decision, I claim, in the year 2000. And that was 20 years ago. So I don't know.
Yeah, I think in Scala's case, one of the reasons was that the language was slightly more flexible with its traits than Java's default methods and interfaces, which turned out that for every default method in an interface in Java, Scala actually had to create an additional hidden static forwarder method.
Yeah, trade forward.
You could
Yeah, but now Scala collections compiles with default methods now. So
Yeah,
it doesn't-
it uses default methods. It emits them, but it always will have to emit these static forwarders because of the way you can do a lot weird super calls, which are basically not allowed from a Java point of view. It's like from a Java language point of view, there is like the JVM decides, well, this is the interface method that wins, and all the others are basically not there. And from the Scala point of view, you can do super and select an interface implementation from some random interface. So and basically jump up the chain or as you decide. And yeah, that's basically doesn't work with Java default methods. And yeah, we have to pay that static method forwarder tax in many cases.
Jamming a square peg in a round hole. You make it fit, but you have to hammer it in pretty hard.
Yeah, the latest versions of Scala, I think they encode trait methods as default methods, the new bytecode. But still, like there's, we use Growl at Twitter, and Growl is much more aggressive at inlining things. But still, like we have like huge performance hits because of basically interface dispatching with Scala collections. You have like classes. I think I spoke some time ago at these meetings about this, but like they have like collections that have like 20 interfaces, and then like the linear search on the interface table is like done on every. So there's like cases that we have today. If you are accessing a collection that is Scala collection, for each element that you get from the collection, you have to go through like 20 interfaces, do like a linear search on them to get every time like every single element of the collection. It's really terrible.
You were working on some way to improve that, I thought.
Yeah, so I was able to improve for like simpler cases, especially when you're calling lambdas, like simpler hierarchies and codes. The case of the Scala collection, the problem, I couldn't optimize it because the profiling information that comes from like the JVM, it's too limited. So you have like a wide range of types that are at that point, that are seen at that point. So I don't have enough information to apply the optimizations that I developed.
You're saying at the bytecode level, you've lost enough information.
Yeah, the profiling information from the JVM, like the defaults, I think it's like 8 types, if I'm not mistaken. And Growl increases that to, I think, 16. And
wait, I'm talking about type information at the bytecode level is limited to, you know, the sort of the basic Java hierarchies.
No,
it's 8 versus 16. Yeah. There's a lookup table that is used for deep hierarchies, and if you blow past the limit, he goes always to the worst case scenario. That's just a compile time constant. A build of hotspot with that number cranked up would be, you know, one-off instant build.
Yeah. So it's basically like the limit for profiling information. If you have a call site, it's going to profile up to X number of types, right?
You're talking about the profile info gathering. Yeah.
How many buckets you have to fulfill until you.
I thought you were talking about the display, the class hierarchy lookup table. No, you're talking about profiling bits. Yeah. Well, that one should still be a compile time constant, but why would you pick 30 over 8?
Yeah.
Over 5,000 over a billion. I mean, what's the number? Why any number? There's a real cost to having it being unlimited in size.
Yeah. The problem with Growl, when I increase the number to a higher number, so there's like interaction with many other compilation phases that end up like producing other bad results, basically. So other things get worse if I increase the number of profile types. I'm planning to revisit that in the future. I'm working on something else now, but basically I'm thinking about like having a stub. Growl has like this mechanism for creating stubs in Java. So I don't need to rely on the profiling information anymore. I can basically have like an internal state in the stub that keeps profiling and then applies the optimizations that I implemented. But I haven't worked on that yet.
I know there are. inlining
Yeah, so
limits. I'm sorry. Go ahead, Arthur.
I was going to clarify. So when you say that you increase this number, is it the number of profiling buckets, or it's the number of cases which would be generated for a call? Because you can profile as many as you want, but you may decide only to generate a switch specialized for like 4 top most common types.
It's a limit for the number of profile types. Right now, if I take GRAL and increase that configuration, I have worse performance. There's a regression. It basically has interaction with many other things that GRAL does in terms of compilation and optimizations.
Like one thing we observed is if we increase the number of types we generate the type switch for, this might increase the code size and lead to over-inlining.
Yeah, you blow out your iCache.
Yeah, but I'm talking about something different. It's more about the profiling information itself, because I rely on the profiling information to basically have like a fast dispatch mechanism for interface calls. It's not about inlining or type switches.
But that's a little bit confusing. So if you like, how does it affect performance if you are not using this for profile specialization of indirect calls?
So if I take GRAL without any changes, without my change, and I run a service at Twitter with a higher value for the number of profile types, I see a regression in performance. That's the problem.
But you haven't diagnosed where it came from.
No. So looking at the differences, GRAL uses the profiling information at multiple places. So I imagine like at some point, like there's something that doesn't fit well. At least with our workloads, it doesn't work well.
You can imagine if you had fewer buckets, somebody falls into the default bucket all the time. A bunch of people run together in some default bucket all the time. And then if you have a lot of cases, but they're all sort of semi-marginal, you probably want to take a generic solution anyhow to save your iCache. And you're better off, not specializing, as Arthur was saying, a bazillion different variants. And you can't, because the profiling data all got confused. I mean, I don't know, I'm just throwing out ideas, but there's interactions to be happening there. Have to go hunt those down. I did a lot of that kind of stuff a long time ago. There's a lot of funny interactions between.
But I'm planning to basically not use the profiling information from the JVM, and then have like a Java implementation of a stuff that's always profiling and does like the optimizations that I do right now for invoke interface.
You're doing optimization at the Java level, basically.
Yeah.
Yeah, I think that's actually probably quite fair enough. Certainly, I was doing H2O. We had to, do this auto parallelization of inner loop things. Where you wanted to do a lot of weird specializations, but the JVM would not do type splitting around loops. So you manually, the Java layer, basically, I could rewrite it, but they wrote it in Java. So whatever you want to call it, split the loops by whatever thing I need to split them by. Yeah, I get it. And I think actually that's maybe the right way to go. I don't know. You have some more secret knowledge about Scala than sort of a generic compiler probably will ever have. Right. So unless you're a Scala specific to raw code optimized thing, you probably know more than the compiler ever will. Take it and run with it.
I believe that the optimization should take place at that level.
Yeah.
In the Scala compiler.
There are plenty of them I know should happen at that level. I know Scala has a pretty heavyweight compiler already that does a lot of stuff at that level. I mean, before the bytecode level.
But it doesn't run fast.
Yeah. Okay. Fine.
And the encoding to bytecode, it's normally very poor. Yeah. When I'm doing like performance work, like I'm normally doing it in Java first because it's much easier. You don't have like much interaction like to what's going to be executed, and then I work on the implementation in Scala. So yeah,
so you're taking profiling data in at the Java layer and using it to change the Java code that you're putting out.
So I was talking more like generically, like normally when I do like some performance work, I do it in Java first because like there's less conversion, right? But the thing about the stub, it's basically like the mechanism from Graal where you can have like a stub implementation in Java that replaces hotspot stub basically. And then I can like from this stub in Java, I can basically always be profiling and get information about the types, and then doing like the resolving of the methods with the optimizations that I have.
Scala does a good job padding the bytecode. Puts lots of pads in.
I'm
So your
sorry.
recommendation for optimizing Scala was rewrite the hot parts in Java.
Yeah, that's a different part. I've been on that path, by the way, and it worked. What were you saying, Cameron? When you say padding bytecode?
If you ever examine the assembly spit out by the IR spit out by the Scala compiler, it has a lot of extra padding, shall we say.
Gotcha. I think the easy padding, the C2 jet will just clean up and not be a problem. It's the higher semantic level stuff that Flavio's fighting through.
I think you're right. I think most of it is pretty easy to peel off because it's mostly store it, load it again, store it again, load it again, and now return it. It's like those extra 2 loads and stores probably didn't buy me anything.
Yeah, that's always, it was I think always a consideration that the compiler could optimize a lot of cases which were simply irrelevant because hotspot would do it much better. And on the other hand, you had like optimizations which require some help from the JVM. I think it's like the biggest and most important optimization is basically specialized generics. Because in that case, Scala C tried to do its own specialization with this optimized annotation or specialized annotation, I think it was called, and it was absolutely terrible. It's like you had this simple tuple type, which was like on the JVM like 2 references in a class, and you annotated it with specialized, and it's not only spit out like all the possible combinations, like 8 times 8 for like a tuple with 2 elements. You had like 8 times 8 types generated, but also these generated classes were a subclass of the original tuple type. So you, for instance, your integer tuple specialized class had 2 primitive integer fields, but also 2 reference fields. And
that might be what bit me.
Sorry?
I did this thing where you're integrating Scala with H2O, so high performance computing, big math, and I write my hot inner loop doing something really stupid like a sum of squares. This is really trivial. And I did all the specialized hacks on the planet and read all the things to try to get to go, and I never got it within a factor of 2 of writing it in plain Java, no matter how hard I tried.
It doesn't work. It's basically you require some help from the JVM with this, and trying to do it in the compiler is a catastrophe.
There was a project called Scalaxy, I believe, that uses macros to rewrite loops, to rewrite collections, and it had achieved pretty good speed, I believe. That's the better way to do it, I would say.
Okay. Yeah. I'm out of H2O 5 years, so that's their problem now. But I tried hard for a while. I spent a couple months at it, and I never got it. Like I said, I never got it within a factor of 2. Ugly.
Yeah, but in the end, the best, the biggest performance speed up is from work you are not doing. Instead of doing it slightly faster, and it's like as long as Scala is using its collections, it will be slow, and you can't basically fix it because the semantics are specified to be slow, and that's basically what people are stuck with. It's like if you do like a list dot map with 1,000 elements, and you take the first element out of it at the end, you still process all the 1,000 elements. And yeah, it's basically if you do like a list.map.map.map, the API is specified to build a new collection after every map step, which also means the parallel collection API is completely terrible and super slow, because these collection building steps between every bulk operation is basically a synchronization point, and there is not much parallelization to be had if you do it like this. And it's
look at the Java streams. They build the pipeline under the hood.
Yeah.
They execute.
Yeah, that's the way to do it. And
yep.
Not sure I followed exactly. What is it about Scala that prevents you from taking a collection.map.map.map.map and just essentially inlining the whole thing to one for
loop? Called Java streams. You just put a wrapper Scala around it and you're done. I'm only being slightly facetious. It's just a different implementation strategy. They define the operator, and you now have what's called bulk synchronous parallel computation. You do a bulk thing, and then you do the next bulk thing, and the next bulk thing. If your bulk things are in terabytes and you can't handle the intermediate representation, maybe it's still plausible. But if you want to then fuse all those function maps and pass over data only one time, the semantics sort of on the surface disallow it. Because they don't say something about incrementally in between, I see half of one and half of another while I'm running around. You go to a Java stream-like semantic. In H2O, we hand inline this to do the same solution, but all done by hand. You fuse all the loops.
So the problem is that each map can look forward and look back in the array. So the whole thing sort of has to exist because you don't know what it's looking at.
I'm assuming that's the problem.
Now, as far as I remember back then, the discussion was basically if people are doing side effects in their collection bulk operations, the order of these side effects will change. And because for whatever insane reason, we are optimizing for the 0.2% of people doing side effects in collection bulk operations instead of for the 99.8% which don't do that and will happily avoid that. Yeah, you're basically stuck with the API and have this view API grafted on, which had like 10 years of constant bugs because it was slightly less convenient to use, so people didn't use it until they had to, and because people don't profile, it wasn't really used at all, and so it was buggy as hell.
This all solved. H2O did it, and so I know there's an API you can write here, but you have to start from a different place. So at H2O, I said, if you did side effects within shared big data and you were running multiple things, they solve them according to the Java memory model on an unsynchronized class, which is to say not a whole lot of ordering guarantees. And if you wanted to compute rollups, which is a comma reductions, that needed no side effects. So the rollups are all done. If you're producing an output, but the outputs were both parallel outputs, those are all independent writes. Those are all sort of freely done. If you did a stencil calculation like an image fuzzer where you wrote back into the image itself, typically because of the bulk nature of things, you were single threaded over chunks except at borders, but at the borders you got Java memory model unsynchronized. Some of you saw before and some of you saw after, and that was specifically so you could write that if you really had to, but you got the performance for everybody else.
And those potential data races didn't make the math people unhappy?
No, the math people were shockingly tolerable because they solved problems at the math layer. So if you wanted to do an update, if you wanted to have the perfect thing, you just made a new image and you bulk wrote instead of updating in place. The only reason to update in place is if you had some performance hack that denied you doubling the size of your big data, which happened. And also you had to do something about an edge case where you're going to update. And there they generally solved it with math. There were a handful of times where we did a thing where we screwed around to make it correct, but only at the edges, and made it difficult at the edges. For everywhere else, a lot of times the math guys would throw math at a problem and it didn't matter. I'm doing some sort of linear regression, you know, I'm looking at terabytes of data, you know, close is close enough. I'm trying to get an incrementally improved thing. I have a tiny, tiny, tiny error accumulation at the edge here. It changed my output result by a max of 1 million elements divided by 1 element's worth of error. Quanta, I did the math. I said, it, you know, it made no difference in the ultimate running time or the value I got out the end. Done, you know, and that was a math guy solving it with a math head.
So the difference, the fact that Scala has to allocate collections on every map, for instance, it's more about the semantics of the collection. That is a strict collection, right? So, and going to like a lazy collection, like a stream or something like that, has other usability issues. And I think like having strict collections in the extended library is the best way for like usability of the language. But still, even if like each map call needs to do the transformation isolation, the just-time compiler actually has enough information that you could say, okay, let's fuse these map calls into a single transformation. And I worked on an attempt at making Graal doing that, but I couldn't make it work. Basically, there's like all these assumptions that the hotspot VM does about like frame pointers and stack frames and et cetera. And I basically have to change that. And that's something that I couldn't make the hotspot VM.
Yeah, don't go there. You want to fuse loops. You need to inline till you got loops in the same function, and then you're fair to fuse the loops.
Yeah, so that was like the problem. Like I couldn't, basically I would have to change the mechanism that defines which stack frames are at which point. And I introduced.
I don't understand. This is like inlining at the bytecode level in the middle of the JIT. It has nothing to do with stack frames.
The JIT code has to still have the basically the frame information, right? So
right, I'm saying you're gonna make a call that includes a map of some guts. But then the result of that makes another call to another map with some different guts, but it's the same collection, it's just different functions. I'm saying if you back up one layer higher, you have a body that has 2 map calls.
Yeah.
At that point, you inline each of both maps, has nothing to do with any stack frames. You've just inlined in the JIT itself, right, in the IR. And now you have 2 loops in the same function, you fuse them and away you go.
It's a bit more complex than that, because the transformation for fusing maps would require transformation that changes the stack frames. I shared a doc.
Yeah, I saw the doc. I'm confused as to why it has anything to do with stack frames, because this is about inlining. Like you're boiling it down to a JVM bytecodes. If you're going to do this, like I could do this in C2, right? Claiming that I saw a pile of bytecodes. This one has a map over collection, a pile of bytecodes, map over same collection. They're called some higher level guy. Okay, I need to inline it because it's all done at doable at C2. Not done at C2, doable technically. I would claim you should be able to do this. Therefore, you should be able to do this at the Scala level, when you're at Scala C level, and hand it down at that point.
So what I was trying to do was at just time compilation time. And the main thing is I have to have a mechanism, because it's a high level information saying I'm able, so I have this collection and you should be able to fuse these map operations, right? So basically, like I wanted to have a mechanism that would allow the developers to say, I'm building this API and you just-in-time compiler, if you see that things don't escape, there's no side effects, apply these transformations fusing operations.
Right.
So it's basically getting high-level information from the user to just-time compilation time. And that would require basically introducing stack frames. And I basically couldn't make it work at the time, but I
I'm still confused as to how stack frames get involved here.
If you look at the doc, it's basically how the fusion is defined. So for instance, like in the Scala standard library, there would be like a fusion class that is a companion of the list class that says you can fuse things this way.
Okay.
And for that, you have to call other methods. But again, like that was like when I started working on Graal, so I couldn't make it work at the time. It doesn't mean that's not possible. Basically, I hit some roadblocks that I couldn't get past at the time.
Are these Scala collections, are these their persistent collections?
Persistent in what sense?
Persistent in terms of a persistent data structure.
Immutable once you have a hook to it. even if somebody makes
Yeah.
delta.
Not internally immutable necessarily, but externally.
Yeah.
The API doesn't care. It's the same API for mutable, immutable, or persistent data structures.
Okay.
Sorry, Simon, you're really quiet there.
Yeah, you back and forth between loud and quiet. Oh, that's it. Yeah, I saw that. Okay, no, Flavio, what I was trying to say was, I want to make sure we don't have a jargon problem. When I say frames, I'm thinking of an x86 stack frame, which is the sort of reified hardware view of some root function at the Java layer, at the JVM bytecode layer, which has plus all its inlines. But not every, so therefore not every Java bytecode. So is that what you're talking about? Because those frames, I would claim, have nothing to do with nothing in code generation, except right at the very bitter end when they get spit out a plus, BP plus equals stack frame size or whatever.
So basically at that time, like I would have to basically introduce and change the stack frames in the Graal graph. And I wasn't able to do that. I wasn't able to do that. Basically, I hit some roadblocks and I couldn't pass that. But it's not. It doesn't mean that's not possible. Maybe it is possible.
Maybe I'm still missing. And you say at the Graal, so you're in the Graal, and there's some sort of border of compilation unit between things. Like in C2, once somebody's inlined, the compilation, the inlining boundary completely disappears. And there's no record of it left. You can't even tell that it ever was there. And I was assuming Graal, running off of a sea of nodes IR, did something very similar, so that once the inlining has happened, you can't tell that there's a frame boundary. There had been a frame boundary. It's not possible.
You can tell when you generate a stack trace, so the data is somewhere.
It's kept, it is, and it's definitely important for save points as well. I think
it's kept for save points, yes, but that's it. Which
the reason I was asking about the persistent data structures is because, and keep in mind I don't have a computer science background, but with a persistent data structure, it shouldn't matter if you do the map operation aggressively or not.
Oh, yeah, that's a good point.
Because you have a stable underlying view whether or not the data is stable.
It's more from the usability standpoint. So users, for instance, can do like a map in a collection, and they expect that the map is going to be something strict, and there's going to be an order. If you do two maps, the first map is going to be run first, and the second one is going to run first. And then people can do side effects there and etc. So it's like strict semantics.
Right, but that's the standard semantics that the optimizing compiler has to honor anyhow. And the loop fusion certainly happens in these things by paying attention to the damn semantics of side effects.
Yeah, but I mean, what he's talking about is like stateful mappers or something, which would be like some frickin' horrible nightmare. So if you ever run into that, just fire those people, seriously.
I think he was talking about classic maps, but with side effects, which you just have to force the element by element side effects, right?
He's talking about the map operation itself, though, right? So I have some data structure, and I say dot map, and I give it some.
Yeah, right.
A comes in and B goes out, and then I dot map, and B comes out, and B goes in, and C comes out, and dot map, C comes in, and D goes out.
Now use all those.
The only way. So it's a striation of horizontal versus vertical when you're doing this, right? So by deferring the map operation, you go horizontal, right? So you go A to B to C, and you go A to B to C for each item, where the other one says, okay, no, I'm going to go vertical. I'm going to go A to B, A to B, A to B, A to B, B to C, B to C, B to C, B to C. So unless you have a stateful.
Where are the side effects coming in?
Exactly. Unless you're either counting on an exception as a side effect or managing state in the mapping function itself, you should not be able to see a difference.
Yeah, in a classic map. So there you go. I'm now, yes. In a classic map, where does the side effect come from?
So if the side effects are...
Somebody's very, very quiet.
Like Frank. Is that Frank? No.
Frank.
Keith.
Can you hear me, or am I still quiet?
There you're better.
Better.
Okay. So side effects are a problem, but if the mapper, at each of these stages, or each of the mappers are independent, then the side effects still happen in each mapper in the same order, whether you do it horizontally or vertically.
I'm asking a different question. How do you write a side effect under the model of a map call we just talked about the map takes a function from A to B.
Yeah, but the function has internal state.
Okay, he's not modifying either the contents of A or B, but he has internal state that has to be honored.
Right, and so
Yeah,
the
fine.
first time it maps A to B, it does something. The second time it does something a little bit different, and so I'm saying it doesn't matter whether you go horizontally or vertically, to use Cameron's terminology, if the state of these separate mapping functions is independent.
Right.
Yeah.
And it sounds like from what Flavio said that people are doing some weird ass shit.
If they're
TM.
dependent, you have to
So
do what vectorizing compiler folks have done forever and a day.
So we're back to your earlier comment. Don't do stupid ass shit.
I mean, a system out print line is basically enough to observe the difference in the semantics, and
you have to honor system out print lines all the way. Yeah. Yeah. If somebody does that, then that stops your fusion. So for my case, doing stuff with the big data math, we had people who did side effects just like I was talking about, like the update in place image filtering games. And
so it sounds like it's going to come down to a little bit, can you inline the entirety of the functions that are in the maps?
Yeah, I think
if those functions are small and you can inline them and you can tell that nothing escapes, then you can roll everything up. But even if I turn the map into four loops in a row, but they each call a function that then goes 20 levels deep, like...
No, that's not, well, maybe that is.
And has side effects that you can't find.
That would be an issue. It's, can you even tell what I'm calling so I can inline them? I think that's a problem for Scala that maybe Java doesn't have. Once you know what you have, and you could technically inline the maps in the same body, and then the functions being applied to the maps are available as static things, now you have to inline them to their utter limits in order to determine that they have no side effects that require a lack of ordering or force you to prevent ordering. Once you see that you have no side effects, like you wrote, like I was doing my big data math, I do sum of squares because I'm doing linear regression. Okay, and, I'm just doing square elements and add them. As soon as I do that, and then and I can inline all the way down, I can see no side effects, and the next loop does something else. I see no side effects. Now I can fuse them and get each of these, by the way, is typically doubling your performance. If you're walking over a big collection, all your time is spent actually touching the collection. So, and the computation's free. Like an x86 has just got cycles out the wazoo, but not memory bandwidth. So if I fuse those loops, it got twice as fast. It's a big game, but you have to drill it down to the bottom to declare no side effects. Or you have to have a typing like a const or a pure or some sort of annotation, something that says this is, safe for whatever.
So Flavio, is that your document that you linked to?
Yeah, I kicked it up. I only got halfway through. It was funner to talk to people. I'll stare at it. But yeah.
Yeah, so that's something that was my first project when I started working on just-time compilation. So I couldn't make it work, but at some points I can try to get back to it.
Yeah, you're trying to let the user write something that would fuse, which is fine. You just tell the user his rules are, you got side effects, you're screwed. Or
yeah, I mean, that's the thing. Contracts are the most important aspect of an API.
Yeah. What we promise you is if you fuse these loops, the order of evaluation changes and your side effect order changes. And unless your side effects are, like I'm doing a lot of sums, those are associative, commutative. I can do them in any order I want.
And a good standard library will have a debug mode where it'll randomly pick which algorithm it's going to use, just to screw with you when you're running in test mode.
I've never done it, but I've totally thought about doing that. So many bugs. Oh, come on, cat. Why are you calling at the door?
Yeah, I mean, building fuzzing to the inside of the system is always useful. So, for example, in clustering, our low-level packet munging software would randomly introduce errors as a way of testing for them at higher levels.
Certainly, when I was doing H2O, we injected
not in production, by the way,
network failures and the like. But like in the land of Java, the reflection give me all methods code returned all methods originally in a random order, and then they declared sorted. and where they went back to random, they had some flip-flop, and it broke a bunch of people who just happened to knew that the order was a certain way. And you know, it's like, no,
Yeah.
stop
I think that there was a period of time where like the order was reversed, and then a few versions later it was like the right way,
yeah, they
the
screwed around with it.
declaration.
And I was both, Cat, you are in or you are out. So Claude, you're in, and we're not having you like mess around with the door. It's like nails on, you know, fingernails on a chalkboard. He wants in, he wants out. No, he just wants to make noise at the window. Stop it.
It reminds me of something that I've often wished that Make had is a random order feature.
Parallel.
So even if you're not running in parallel, you know, you've declared your dependency tree. Make should be free to do things in whatever order it feels like today.
Yeah,
which might be different than yesterday.
Yeah, you have to make it
There's a lot of-
deterministic on a seed. Like there's a default seed, I flip it every time. If you had a fail and you're curious, the seed is available so you can force the repeat.
Oh, yeah. So you have to ask for this random thing, and maybe the option is a seed to tell it, you know, how to figure out the order. But it ought to be almost ought to be the default behavior so that people don't.
We did that in
Don't rely on-
H2O. Now that you've said that, we had these big data tests. We would often build large data frames that were expensive, relatively expensive to build, do all these tests on them, and they were supposed to all like return things to the normal state so the next test could run in any order. And we would have cases where people would side effect and delete columns because that was what they were testing and not restore them and the like. So we put a seed on JUnit that would flip the order of the tests. And in a part of the damn, who's the guy, your continuous integration, Jenkins, would print the seed that he picked at the start and then go to town. And you could get the seed out if you thought it was related to an ordering of tests execution. You could get the seed and repeat the order. Yep. We totally did this at H2O. I had forgotten all about it.
The method ordering the JVM it's still important. So as part of the interface evoke interface optimizations I was working on, I tried to change the ordering because then I would have like a better layout for the optimizations. And basically there's a bunch of places within the JVM itself that breaks when I change the ordering of the methods in basically the virtual table.
Yeah, there's a lot of folks who have secret, strong knowledge of the virtual table layout, including everyone who wants to add new methods has to fit them in the holes on the table. There were like 7, I don't know. At one time I screwed around with this a very long time ago. This was way in the early days. So I screwed around with that and then gave it up because it had to do with like class loading orders and class initialization and stuff. Like you'd have slots in the table set aside for class that was loaded but not yet initialized or whatever. And I don't know, it got weird fast. And I was like, I'm chasing too many other bugs. I'm not going to chase this one anymore. I backed off and went a different way.
And you held down the space bar to overheat your CPU, apparently.
And I held down what?
You haven't looked at the latest link, have you?
Oh God, Hirum's Law. No, I haven't.
You gotta look at the XKCD on it.
Yeah, it needs to be an XK. Oh, it has an XKCD. Yes. Okay. Yeah. Yes, every user, sufficiently large number of monkeys will type every possible attack on your system. And then they will depend upon all leaky abstractions. I totally get it. Yeah.
The guy who wrote SQLite talks about that. He's like, I really thought we had found all the bugs in SQLite until they baked it into Android and shipped it on 1 billion devices. And
Yeah. You know, Hotspot and Java kind of paid a price in the beginning for a while to force that. There were a lot of folks who had a lot of baked-in assumptions, and somebody up high at the JavaSoft was willing to bust people to preserve the quality of implementation choices. And then eventually became Brian Getz, who has been in that camp for a long time. I mean, now he's stuck pretty hard, but he was pretty good at saying, okay, this is screwed up. We're going to change it to be not screwed up, and that's going to break these people. And then the community got bought into it and said, okay, we'll take a more pure answer.
Well, he's
no
also
longer-
done a really good job at backwards compatibility. So even though a few things have broken, it's overall been really good.
I just read the XKCD and I configured Emacs to rapid temperature rise as control. And I can see somebody doing that. Oh my God. Old users get their configurations more and more accreted into weirder and weirder things. And not that I'm ever guilty of such a thing, but yeah.
I guess the Java backward compatibility question is largely: do you run on the class path or do you run on the module path? And if you're trying Java modules, you basically have no compatibility. It's like just be totally.
Yeah, but you opted into that.
Right.
Yeah, true, but
I didn't want to screw with modules.
Yeah, there are a lot of people that just stayed on 8, and that's why it's so stable now.
I'm on 8 to this day, and I have clients I've shipped to on 8, and I know plenty of clients who are running 8. Yeah, yeah. Oracle like put the pedal to the metal on the release wheel, and like a whole lot of people looked at them taking off and like, see you later, bye. You go crash into some far distant wall way down there. We'll wait. I might.
It's a pretty good
flip to 11 after a while here.
It's a pretty good model though, because what they're saying is it's the we're not going to promise you what you're going to get on a certain date. We're just going to promise that every 6 months, whatever is baked gets released.
No, I have no problem with the whole release train model. What I had problems with was they kept adding new features that impacted the existing setups like a lot, and wanted me to go find and fix all their bugs by flipping to their new features. There's nothing to do, like if I just kept my 8 code base and I flipped to 15, how much of my shit would work, including performance? Like I'm doing high performance work. So I'm expecting performance to work. I'm expecting the code to run without crashes and bugs, without it complaining about use of new keywords or I don't know what all.
There's generally only one thing that breaks when you go past 8, and that's the adoption of the module system.
Yeah.
And if you're a beginning developer, it's not going to break you because you're not doing anything complicated enough to break.
I'm doing a new project from scratch, maybe. I don't know. Fine.
Yeah. Even if you're doing a new project from scratch, for instance, like you're using a library that depends on this findbugs JSR 305, and you are trying to use a web API like JavaX annotation. It's broken. It doesn't work. It's like it's not working under the module system because they both claim same package name, and I guess it will take another 10 or 15 years until people start dragging in JSR 305 transitively. And there is basically, if you're using Maven, there is no solution except excluding it individually on every dependency, or you use this band dependency Maven plugin, but that's another story. But it's terrible. It's yeah, it's broken on so many layers. It's hard to believe. I mean, they basically threw back the adoption of the Java module system by 2 to 3 years simply by deciding that this module info file is added to the jar as a .class file, which basically broke all third-party jar scanning class analysis tools, which a lot of companies like depend on.
Yeah.
And it's like they could have chosen, they could have used Java bytecode, no problem, but they could have basically chosen every single file extension they wanted except .class, and it would have been 2 years faster for everyone involved.
Fine.
And
let's all agree to hate modules and move on.
I mean, they are nice if the alternative is that you are basically depending on what Maven tells you about your dependencies. Then it's a clear improvement because Maven is terrible and slow and barely works. But except for that,
I have carefully avoided having all these issues in my life, and I use Maven, but I don't have these issues. But maybe I'm special, so fine.
one thing people will surely love is the change to a UTF-8 by default in the JDK. That will break so many people. It's so basically you had like these old style APIs where you had the overload with charset, and if you didn't use the overload with the charset, it assumed charset. I'm not sure what's the class called. It like assumed the default charset, which was weird stuff on Windows, and that's being changed to UTF-8, and it will be fun.
Yeah, it was some sort of ISO 8601 or something like that, or 9660 or some. Yeah.
I did a TCPH hack on Julia for this company I'm doing contracting work with. And I wrote a border more algorithm, which looks at bytes and strings and tries to cite a pattern match, because that's exactly what the old school SQL that's in TCPH wants. And of course, it's all ASCII data because it's an old benchmark and all this kind of shit. And lo and behold, Julia supports every kind of weird character thing and has to do character UTF-X character scanning, inner loops on outer loops for everything. And it was horrifically, so 10 times slower than the Java version, which I had just, jammed it down to look at bytes, and the bytes on bytes on bytes on bytes, and it's all fast. And it took forever to sort out and make Julia not do strings and not do characters and not do UTF-8 and make it, screw around with bytes. So yeah, any change that says I went from cars or bytes to UTF, yada, yada, that is going to, I can
well keep in mind that it's all hidden inside string. So your contents, I believe it's actually, the field is called contents, is a char array, but it's private. It's inside string, which is value. A final class.
It's called value, right. No, but you have a car at on a string, which effectively treats it like an array of shorts or cars, Java cars, not Julia cars, which has the array behavior you expect out of an array of bytes, an array of shorts. So fine. Julia had an inner loop to go fetch a character because he had to decide that you were a UTF and he was going to rate 1 to 4 bytes and hand them back to you in an int. And I just wanted, give me the byte because I'm doing a byte by byte comparator.
That's hilarious. I was just working on timestamps, which is why that number was in my head.
Oh yeah?
That's all the isn't that all the formats with the D and the Y and all that? Yeah.
I did. See, I did that. That was what I did. So you're talking about time formats. I did this stupid financial transaction company, fintech fraud, right? We had these fintech files from 70s, 80s, 90s, 2000s. Every single exchange had a different format for time as encoded ASCII things. The month would be a 1 byte uppercase letter, 12 out of the 26 in the alphabet, but it varied by exchange. Sometimes it varied by product, because if you're on commodities and corn futures have been traded since the dawn of time, they had a different layout than other people. And I'm blaming corn, but I remember there were multiple different things, and commodities especially had this ugly thing. And the contracts were like, this contract expires in so many months out. Some of them were delta, and some of them were month, and many of them had a year boundary that was a 1 byte for just the tail of the year. So it rolled over every decade. And it, like I said, everybody had a different freaking time format. It was just crazy. And of course, you had every time zone. And most of the exchanges, when you wrote your thing out, you knew the time zone it was written out at by the exchange, where the exchange was placed. But the guy putting the trade in had to have a log on his side. Some of them logged their local time. Some of them logged the exchange time. And you had to like stare and guess and figure out which one they logged. And the exchange had their own time, which is usually local on them, only, and no one ever wrote a time zone in these log files ever. So you just had to go like, I don't know, we had 1,000 lines of code to go deduce time zones. It was ugly. Not counting all the, you know, fantastical time zone converters. You picked up Joda times. Like Joda's pretty good. You picked up Joda, but then you had 1,000 lines of heuristics saying, oh, if you're at this exchange, with that exchange, with this, look at the delta between the first 1,000 transactions. If they're all consistently off by 3 hours, we know it's this versus that. And then, you know, it was standard time versus daylight savings time, had an hour or not, according to whether the exchange honored or the local guy honored or didn't honor it. And you're looking for like wash trades between two exchanges, between one guy in the middle, and he's taking things and like swapping them across exchanges in an effort to show volatility or traffic motion on a product, but he's just selling it to himself across two exchanges. And he had to catch that as a fraud thing. So now he had to do like triple time zone equality relations. And once you got them all on universal time, it was all easy. Oh, these all transactions and this guy all recorded identical times, bang, fraud. Get them all in the same time zone, nightmare. Fine.
Did you still want to comment on that paper in a way that doesn't fit in a tweet?
Which one are we talking about now? Comment on the...
When we first started, you said you wanted to correct something you said about paper.
Oh, go back to the paper thing. Oh, yeah, okay, like, why are compilers slow? Okay, I claim that that's an opening false statement. You know, C2 is not slow. And he even gives some examples of not slow compilers. Oh, ahead of time compilers are slow. No, C2 could be totally run as a ahead of time compiler. It's not currently, it totally could be, has nothing to do with nothing. Ahead of time or online had nothing to do with speed. So that was, you know, opening statements like baloney. Somewhere in here he says, and peepholes are always done on machine code. No, C2's 90% optimization C2 are peepholes done on the high level IR. And he had a bunch of other claims here about
compiler performance is also dependent on the language. People like to complain about C++, and I think the single largest contributor to the performance problems there is the availability of overloading. Right?
Well, that's the Scala people's problem.
You know, the name, particular name meant one thing and one thing only.
Yeah.
There wouldn't be any time spent on figuring out what it was.
Yeah, right. And so Java went to the route, and C++ went to the route. Well, okay, in the beginning, C++ went the route. You had single inheritance. You had a V table, did the right thing. You took an indirect call. It was a load jump register. It had a fixed known, expensive, but not too bad.
About binding a name in the source to a particular declaration, right? So we have a class hierarchy, even if it's single inheritance. This virtual function may be overloaded 17 times. Which one are we talking about?
Yeah, and that's why CFront would extend the names. If you remember the C++ name mangling garbage.
Yeah, name mangling.
So you'd get an error. You know, you'd write a 10-line program and get an error back that was 240 lines long.
Well, that was an error reporting problem, not demangling. That all went away when people got dedicated C++ compilers.
I still hate it.
Compilers with name mangling.
Still hate it.
Okay, fine. But I think finding the right one in a single inheritance hierarchy is sort of straightforward. You have to put a runtime test in. That's the V table call. There's a virtual call. Java did the same thing. Plus the observation, you could do a caching for performance. And then they threw in interfaces, and C++ threw in multiple inheritance. And both of those like dict with how you figured out where things went and how you could efficiently dispatch to them. And that was sort of the beginning of the end. If no one had an interface call, which I don't claim is the right answer, but if no one had an interface call, all Java calls would be a fixed either 1 clock or load jump register 30 clocks. But you knew it was a known reasonable cost. And the lookup's not the issue here at compile time, I don't think. The issues like the compile speed problems of what you're talking about for compilation speed, that's all done at like parse time. Or at least it is for everything I've ever done.
I believe the speed also correlates with the type system. The more complex, the more time it would take.
Julia's type system can be driven into holes where it goes like exponential and dies. And also
macros.
Oh, okay. So I'm not talking about macros. So in typing I've done for AA, which would totally cover like Java and C and probably most of C++, the typing is guaranteed linear with actually pretty low constants. I can type these systems really fast. So there is a way, at least, to do fast typing on those systems. You get a more complicated overloading game, I don't know necessarily. Any of the hunt for it answers that go exponential look pretty brutal and bad to me.
Yeah, that's where we spend 90% of our compile time.
Is it really?
Yeah, easily.
Wow.
We produce a data structure that answers every question, but producing that data structure takes 90% of the compile time.
I'd say we should have a discussion about fast typing systems, because I can type.
That would be cool. That would be cool.
Where you want to go down that route? That's like there's already 11. This is a different path. So the first thing is you have to see if what I'm talking about maps to what you're talking about. If there's any way to do it, right? Because if there's not, then there's no point. But I know I can do a hell of a lot. This is lattice theory. If I can squeeze your language into lattice theory, and I can squeeze a hell of a lot of languages into lattice theory, then I can guarantee you fast, optimal typing, probably even without any type annotations. So this is C2 typing internally is lattice theory, and all types are interned upon creation of the first ever IFCA type. I intern it immediately. Then type comparisons are a pointer equal pointer check. That's it. Because it's a lattice, subtyping relations are all done with meet and join. So meet produces a new type that I immediately intern, and you intern it incrementally as you go, but meet turns into structural recursion, except that because of interning at every step, the typical answer is that you go one layer in on a type and discover all the subparts are equal and you're done, and that's your subtyping test.
Can a dependent type system fit in a lattice?
So when you say dependent type system, what do you mean? I'm not doing generics. This
no,
is
it's not generics. It's like instead of saying int, you would say int between 3 and 7.
Oh yeah, that's fine. Ranges are fine. I do ranges right now.
In a dependent type, a value can produce it. A type can depend on a value. So if it's a 3, it's an int. If it's a 4, it's a boolean. Yeah, that basically that's what it means.
So what I have is that any individual integer or range of integers is a type. Same for floats. Same for any statically declared, like a constant string is a type.
They would qualify for as a singleton types, maybe. Yes.
Yeah, but
the 3 is a 2 is a type 2 also.
Yes. So there's no carrying of, there's no singleton type as a special thing. Singleton types the only thing they have is that because they're turning a single value, there's a clear optimization strategy that follows on. But as the typing system goes, singleton type has no special meaning. It's a member of the lattice. It happens to sit below or above, depending on which of your head's spinning, the integers, and it has no other special property other than it's a member of the lattice. Pointers are members of the lattice. Alias classes of subtyping, aliasing is partial in the lattice as well. So, strings and arrays of strings and structs and like tuples are structs without field names as a member of the lattice. And so a tuple subtypes a struct because it has no field names. Is that kind of get it? And so I can say, give me .0, .1, .2 field members of a struct. Well, that of a tuple. Well, that works on a struct as well because a struct is a super type of a tuple.
Well, it's some kind like a Scala case classes mapped to tuples almost transparently.
Okay. Yeah, maybe. I'm not. I looked at case classes a while ago and I haven't looked now. So I have tuples in the lattice, structs with field names. Properties on the fields, like it's read only, it's write only, it's written once to, that's all in the lattice. Function pointers are in the lattice, display closures are in the lattice. There's a different thing. Collections of function pointers are in the lattice, so I can have generic collections. I don't know what function we're talking about. And first class functions being passed around are all in the lattice. Memory is in the lattice, so I have loads and stores operating contents of memory. The contents of memory are all well typed.
Testing for a subtype in a lattice, does it fast? Does it work well?
Yeah,
if one type is a subtype for another type.
mostly that's what I do, and that is the main operation, right? That's with a meet or a join. So the is-a test is A meets B equals B. A is a B if A meet B equal B. So I do a lot of meets. Okay, now what's A meet B? Well, it's structural. So first I ask, are you the same basic type? If you're one's a memory and one's an int, that's a fail right away, and you drop to the error type. There's an error type all. There's any is the inverse of all. So all is the, you know, the bottom of the universe. That's basically only errors go there. But if you're both, say, two structs, then I can say, okay, you're an is-a if do field by field. And then structs have another property, they're open or closed, which typically they're all closed past parse time, but while I'm parsing, I also type. And so I get my typing incrementally, character by character as I parse.
Do you get into any trouble with multiple inheritance? The thing I think of is like messing with lattices is if you have like A and B that are each descended from C and D, and you get that sort of hourglass.
Okay, thing. So yeah, so let's separate out. So I'm not doing C++ multiple inheritance. So we're not talking about that. We're talking about lattice shapes. What you just said was a lattice shape. Okay, in the lattice, to be a lattice at all, I have to prove a bunch of properties around exactly that. If I can show those properties, and totally like all integers have a 2 and a 3 and a range of 2, 3 kind of thing. So these things show up all the time. If they fit in the lattice property, then I'll have my fast, good, constant time. I guarantee you a best possible typing that I'll find in linear, quick time, blah, 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 blah. All the right properties show up. Yeah, and so I went to Hindley-Milner because I can't do polymorphic types in the lattice. Right, so this is no generics, right? So I could do Java without generics, sort of quick and easy. Now, I know Cameron has like mixins, and I don't know if mixins fall into this category or not. They may or may not. I can do nullness and not nullness checking sort of freely in the lattice. So you can say I want a nullable type or a not nullable type, and that all works as expected. The big one I'm missing right now is generics or polymorphism, which is what I'm screwing around with integrating Hindley-Milner in this typing system. So if you're not doing generics, I have a fast, guaranteed, sort of pretty much guaranteed optimal. I think a very strong notion of optimal, both on the quality
for
and
for generics. Do you think that's some viable approach to include them in the lattice?
So for true generics, so I say true, really polymorphic types. So not Java generics with you erasure or whatever, they give it up at some point, right? But really polymorphic types, like you get out of Haskell or ML, right? I need the Hindley-Milner algorithm. And so now I'm in the lane of research because I'm integrating Hindley-Milner in my forward flow typing, and I've come a long way, and I'm not there. I'm getting side distracted by my consulting gigs and whatever, but I've come a long way. I think I'm going to get there. I have taken Hindley-Milner, I've made it into an incremental work list algorithm and preserved all its good properties. I can take Hindley-Milner types and use them to lift elements in the lattice where I otherwise would have to omit. So the typical thing I would do in the lattice is if you have a map call and it takes a bunch of function parameters that it then applies to something and you get a result out. So you take a collection of A's and a bunch of functions from A to B and you get a bunch of B's out, right? But actually the map takes a bunch of collections A, B, C, D and a bunch of functions from A, B, C, D to E, F, G, H or whatever, hell. Well, as soon as it takes collections of A's and B's and C's, it fuses them and goes to the worst common type. So the map takes something that's a scalar, any possible thing, and a function from scalar to scalar and produces any possible scalar out. So I lost it all at the approximation point at the head of the map call where they all came together. Okay, Hindley-Milner pulls that back out. And he says at the exit of the map, the typing system, the lattice type says you're only a scalar, but I know since it was A's on this path in and a function of A to B, it's B's on this path out. And this other path in took C's and a function of C to D and da, 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 da. So Hindley-Milner lets me lift things in the lattice and I have that piece going. And there's a reverse problem where I mutate the graph based on the knowledge I have locally to change it or to improve my typing ability. I have to go back and retouch the Hindley-Milner types, which I'm still like orbiting around and heading for closure on. Along the way, by the way, I handle the occurs checking, I handle recursive types. So Hindley-Milner's recurse check I can just blow off because I'll just get a recursive type out, and that's fine. And I live with recursive types, and they're happy in the lattice, and that doesn't matter. So I have a bunch of weird things I've done in the Hindley-Milner that have made a bunch of progress, and a bunch of things the lattice is fast and efficient, but doesn't do polymorphism. And
It's definitely cool. I would check it out. It's cool, definitely.
Yeah. So AA is the standard lattice thing with lattice from Heck, which I do. I talk a bunch about. You go to the where's the good type.hpp is probably the right starting point for all things lattice. Let me actually go, because it's like a big ass program. I'm busy doing. Oh, here we go. No, yes. Okay, HM is my current hack mode. You know what that? Type, probably type.java.
So when you say big ass and you combine that with your love of terse, is big ass 100 lines or 1,000,000 or somewhere in between?
Well, big ass means, terse, plus lots of code. So there's some subtleties there. Depends on where you want to start from. So Java doesn't give me a way to directly support efficient interning. So I'm all accessors to go make anything that wants to be efficient, fast, starts with, you call a factory, which interns under the hood. So that kind of makes things a little uglier. So you don't say new type, you say type.make. And it's type function pointer make, type mem pointer make, type int make, type float make, blah, blah, blah. And there's a lot of them that say, I'm going to make a delta off of this type. So type function pointer make, but change the display, the closure, the environment variable to this other thing I have in my hand over here. Type struct make, which is that struct, except change this field to this thing. Because it's immutable, it's intern, so it's immutable. Everything's immutable. So that's, big ass hash table for all the immutable versions of things. And every constructor says, pulling off a free list. Don't do a new. Fill the fields. All fields are not final. They cannot be final because I'm filling them. Look up in the hash table. If they get a hit, take this thing, put it back on the free list for the next go round. So no memory allocation happened in that path, and that's the 99% case. And that's the reason it's fast. If you miss, oh, well, stuff it in the hash table and go make a new free guy for the next go round. Kind of, that kind of game happens a lot, and so it obfuscates the code. But the actual lattice is sort of straightforward. There's a bunch of tests on lattice structures where I abstractly represent a lattice as just like one line per obvious element in the lattice and put a Java code, and then I run through and verify. In fact, you have a lattice. So if we were to go take, Cameron's issue and say, okay, let's put Cameron's entire language in this lattice theory, I would start by saying, make an abstract instance of this test lattice code, and ask it, do you have a lattice? And you do all the obvious things first that are latticey things. I have subtypes, and I have ints and floats, and I have primitives and blah, blah, blah. And those are all lattice, and you ask the question, you get back to the lattice. But you have a bunch of bugs in your description. He points them out to you and says, hey, you have not minimal here, you have extra edges there. This is not quite balanced with that. You failed, but you fix all those. Now you come along and say, okay, I want to add mixins. What's a mixin look like in the typing system? And how does that sort? And maybe it becomes a lattice and maybe it doesn't. Like null does not fit in a lattice horribly. You would think null would be an easy element to put in a lattice. It's the center line. Turns out it breaks all your lattice properties. And I can show you on Wikipedia for the lattice page exactly which pattern that is not a lattice and why. And if that subgraph ever appears in my lattice, then it's not a lattice, and my lattice tester will tell you it's not a lattice. And null lands squarely in that category. So I have a signed null, like nil, like null, the C null. I have a signed version. There's one that's just above the lattice, exactly above the center line, and one just below. There can be nothing in between, or it fails other properties. And the one that you get when you type 0 in the language, which is the canonical null I have for everything, is the above center one. But there's a below center one for symmetry and for completeness. And it shows up if you're debugging, but you never see it otherwise.
So why have a null?
I'm sorry?
So why have a null if it
Because
creates
it's
so many
convenient as an
issues?
abstraction saying not available. I have a not a number, I have not a number, not a pointer, not a thing. It's the missing element. It's not here, and it has hardware properties of extreme efficiency in a lot of fronts. It's a good initial value for things. There's a lot of like, go make a cyclic data structure without having an initial value for somebody. You have to break the cycle somewhere. What's your initial value? Null's pretty good. So I have a strong property of a null, and it does all the right things you expect out of C compiler, as well as being strongly typed in all possible ways. And you can be nullable and not nullable and have that all come out like the Kotlin kind of properties. Those are all there. So I like my null. It's a good canonical first value for things, and it's a good missing. I don't have one of these things.
So you have any for a type for the bottom or the top, depending on the
I have
vector?
an any and an all.
Do you have the opposite, the nothing type in the Scala?
We lost Arthur somewhere. I have, null is, okay, so I have an any and an all, which represent basically error extremes. I have a null, which is where I use what Scala would say null or void or unit. That's my null. And it's in the lattice in the right place and has all the right properties you expect out of such a thing.
The other spectrum of the any Scala has the nothing type.
Right.
Type. Yeah. So, nothing, not null, nothing.
Okay, I have an any and I have an all. So it depends on how you want to declare your naming convention.
Okay.
What is the Scala nothing? What does it mean?
Actually,
I think his nothing is my null, not my all or my any.
No, so the nothing in Scala is a type that has no members.
Right.
Basically.
It's essentially
it's the bottom. It's the bottom type.
Okay, it's not what I'm calling
from
bottom.
Null.
Yeah, it's different. It's not what I call bottom. My null is as close as what Scala says nothing. That's the right.
Is nothing void?
No, nothing is a
nothing
type.
is the.
I think
I usually find that nothing is easiest to explain going backwards. You have Booleans that can be true or false. They have two states. You have unit that can only be null. It has only one state. Nothing is the thing that has one fewer state it can be in than null. If you ever try to instantiate one of them, that is an error and your compiler should get mad at you.
You cannot instantiate nothing.
It is the thing that cannot be instantiated ever.
Yeah.
But you have a name for it. And so why do you have a name for it?
The way I like to explain it is to say, if you look, you have two methods. One method returns void, one method returns nothing. The difference is that the method that returns void returns. The method that returns nothing will not return normally. So it will either loop forever or it will throw an exception.
So it's a non-completing.
I would claim I would use a different, but maybe that's an interesting one. So I don't have a void return. I have a null return. All functions must return a value, but they can return null. There's no.
You have a way to mark a function as this function will never return?
I could. I don't. I don't think that would make any difference to me in the typing system, though. I would claim that's a property of a function, not a property of a type.
So if you look at the type system from the logic aspect, the nothing is basically false. And everything that has a member is true. And it's very useful. So you can have like APIs where you have a generic where you can use nothing to specify like a specific situation where you can't really call that methods with that type parameter. It's very useful. Maybe it's worth taking a look.
Yeah, okay. The other questions were any and all, and that's just a naming issue. I have structs, they can be named, and that's your subclassing. And the names have a hierarchy that ends with no name as a version of it. And I haven't decided where to go from there because I'm screwing around with polymorphism first. I got enough subtyping done to believe I can do it sort of really, and then I walked away and said, let me get polymorphism. So my take on names are a little different than what you're thinking of. So if you want to say like object in the Java hierarchy, I would just say it's the empty struct, which for me is actually a tuple. It's an empty tuple. Fine, I have that, but it's not bottom or top. because below a tuple is any or all. Sorry, going below be all. So there is a
Are
lowest.
all empty collections the same? So like is an empty list of ints the same thing as an empty list of strings?
That's a different one. And again, I haven't decided where to go. Right now, my arrays are all strongly typed. And I'm kind of, so the array itself is typed. And I'm going back and forth. Like the array is untyped and has what it has. And maybe I happen to know that it has all ints. Or the array is strongly typed, in which case you have the problem of I have an array of object versus I have an array of Java integer, and I cast it up to an array of Java number and have an array store check. Do I want to support array store checks? I don't know. I found them clunky, but conceptually kind of nice. It's not typically a problem other than you have to throw casts in funny places. As soon as I add real polymorphism, maybe the problem goes away and I can be strongly typed and not have any cast issues. In which case,
with
yeah.
With a reified type, though, you can have both. I mean, you can theoretically generate both code paths. One where you know it's that type, so you don't have to have a check.
That's an optimization.
Yeah.
Where you're claiming, yes, and I'm totally there. Like in particular, I know that I want to boil all primitives down to an array of that primitive, right? So I want to have a generic code that says I have a hash table that are hashing keys to values. The keys are integers. It's an array of ints, not an array of capital I integer. Whatever, however you implement that. So that's a polymorphism thing going down to a primitive. And I do that actually. I'll look at whatever typing I ended up with, and then if I decide I have a reference to a primitive and a reference to something else that's a different primitive or a different non-primitive, I'll start code cloning basically in the typing system till I get it statically done. That's a case where the lattice tells me I have a mix of things, but it can track them all. But I want to have as a optimization property that I don't have a mix of primitive types in the same structure, in the same array or the same field of a struct or whatever. In this case, I do code cloning to fix it. And no, I haven't figured out how much code cloning that turns into.
Yeah, it's not an exponential amount though.
I think in practice, it will not be exponential. I think there might be a case where I can derive an exponential badness.
Yeah, and it's also an easy thing to budget in that you can count the number of times you do it. Yeah. And then
that's already been in the plan too. It'd be, what I'll do is I'll say, you can ask for syntactic sugar and I will auto box you, but I won't auto box by default. Unless you blow out this configuration to an extreme, and then I'll say, I can't efficiently do this. So you have a typing error, because otherwise I just autobox, and then you put in the autoboxing is okay flag type, actually it's type, and then I'll autobox it at a much earlier stage and get rid of all the exponential growth, and we're all happy now. But you have to tell me you want to be slow before I'll go. Like there's some syntactic sugar that's free and some that's expensive, and autoboxing can be expensive, so you have to ask for it.
And that ask is as simple as annotating the type when you first create it.
Yeah, or the function or something. Somewhere it goes. It probably goes on some dependent type, yeah.
So instead of saying list 1, 2, 3, I say list of any 1, 2, 3.
List of, autobox. I don't know what the right phrase is going to be, but yeah. Yeah.
What was Jim's question?
Really. I have arrays. I hate lists.
What is Jin's question there?
He had a paper question. We talked about paper a little bit.
Yeah, hello. Can you hear me?
Yeah.
Cool. Yeah, I finally fixed this mic thing. Cool. And the thing I want to ask is, there are like hundreds of rules of rewriting in C2, right? And I found similar rewriting rules in LLVM's instruction combine. So basically, they are the pit hole rules to get like a better code. But after I reading that paper, and I was thinking like, why do I need to write those rules one by one? Can I like automatically generate those rules, because it sounds like, you know, 2 instructions into 1 instruction. That's like a no-brainer. That's a no-brainer better code. So is that possible that we can write an algorithm to iterate all potential patterns and generate those rules one by one? Let's see that we number them like 1 to 1,000.
Okay, Zin. I want to say go for it and see, but there's some obvious fails here. Where do you pick up the property of add of 0 is an identity? You're not going to discover that. You have to be told that one.
Semantics. Okay. It's already done. It's already done. It's already been even used for LLVM people derivation.
Somewhere in LLVM, somebody has a note that says add of a 0 is an identity.
Yes, that's what I'm talking about. Okay. So you can derive those semantics automatically if you have some theory. I'm talking about theory in the sense of SMT, for example. So do you know the difference between SAT or SMT? So SMT is satisfiability modulo theories. So you could check for satisfiability of Boolean formula given theory of integers. And this is where you put the knowledge that x plus 0 is equal to x.
So you have the knowledge in there. It's in the integers that you've encoded in your implementation of So I'm saying it's not a thing. Okay. So repeat that for every possible theory. And now I claim, you know, you're not automatically generating peoples, you're just encoding them in a different way.
Yes and no, because you can also generate the preconditions, and that's the hard part. I can post a link to one paper which shows the problem in a very, very simple and short way.
Maybe we're having a confusion between peoples that's done at C2.
Take a look at this paper right on the first page. Just right on the first page, there is a peephole for is power of 2. It's a very simple peephole.
Yeah, Matt, when you say semantics, do you mean like x86 instruction semantics?
So depends, you can have both, but you don't need to. You can have also semantics of LLVM-IR. So do you see this peephole for is power of 2?
Yeah.
So the interesting part is the third part, the precondition for when this peephole is correct. And that part is often non-trivial, and that part is often buggy. That's actually one of the most buggiest parts in LLVM, and I believe in GCC, is developers getting the preconditions wrong for the peephole rewrites.
Okay.
So automating this part together with the derivation, that's where the value comes in.
Yeah, I think we have a nomenclature issue. The C2 peepholes are done at a different level, and they have a different issue with precondition semantics. A typical precondition is you're only identically matching a pattern shape, and the pattern shape is sort of really quickly just based in part of the pattern. And I don't do it at points where I see this kind of overflow, underflow math.
So that's interesting to me. And the value where I derive this myself is doing this for floating point optimizations, because there are sometimes you have an idea for a floating point rewrite, and IEEE 759 can make those 754 can make those ideas a bit tricky to check correctness of.
Java said, "Thou shalt not reassociate. Thou shalt not commute." Not commute, but thou shalt not do a lot of things with IEEE float that you would otherwise do. So we didn't do it.
Yeah, I mean, checking this can be tedious, especially if you have those different modes of floating point environment support, when you have to sometimes care about -0 versus +0. Yeah. Sometimes you don't, and you really want to know which peephole fits for which floating point support level.
Java threw those away, so we didn't have that problem.
And it gets worse with decimal as well, because you have multiple cohorts for the same value.
And Java, nothing there.
This is where I see the value of this, and what Shin talked about. There's the other thing with the peephole derivation given the semantics of the ISA. So the showcase for that is the famous population count rewrite. You know, like x86 has this population count, pop count instruction, and you can recognize the loop that does it.
Yeah.
And that every developer knows pop count, probably, at least it's fairly well known. But there are many instructions which are not that trivial. For example, what can you do with the AVX512 Galois field 8 instructions? Well, you can actually do matrix transpose with this. And discovering that automatically may be a bit less trivial. So I think...
Yeah, but I'm claiming it's not interesting either.
Well, if you can lower latency on the benchmark that is interesting to your customer, then it is interesting.
No. I'm claiming that any transformation that requires a single custom instruction to be applied is a thing that you just write. The effort to write it in a stat solver versus the effort to write it in a C2 is like night and day different. There's like 3 lines, 5 lines of code you write in C2. You have the pattern.
Yes, but correctness check. But you have the correctness check.
And then you have to test the correctness, which I claim isn't take that long. It'll be the hell of a lot faster than writing a stat solver.
Well, but the question is
scalability. Solvers are done.
No, you have to write the language into the stat solver. You have to write the problem domain into the stat solver.
Yes and no. I mean, say if you take the ARM processor, if you take the ARM processors, for example, nowadays they give you machine readable semantics themselves. You can download this from ARM. This is machine readable, and it is usable out of the box.
Go to town.
Unfortunately, Intel doesn't do that.
Yeah.
But
fine.
It's too complex. So the thing is, Cliff. So what I'm saying is that usually compiler developers spend years and years to develop those like optimization, like p-hole optimization. They discover those kind of rewriting rules year after year, right? But even though we cannot provide all of them, because I feel that after I reading that paper, I feel that if we define some kind of rules or semantics,
yeah, I hear you.
We can run a program to discover like thousands of more.
But like I said, go for it. See how it pans out for you.
Mm-hmm.
I think you are years and decades away from catching up to what took me a year to put all the infrastructure in place, and people's then dribbled in over time after that. But there was a solid year of register allocation, parsing bytecodes, building SSA form, building type inferencing, building all these things, which people's were a small part. And then another year of gradually widening out the people set and fixing all the bugs. Most of it was done in 2 years, and people's have dribbled in over then. But that's it. The 99% case was covered within the first couple of years, and then the 1% have been added on gradually over time.
Well, all these whole transformations can be added to some existing infrastructure. So we are talking about register allocator and other infrastructure parts. Like nobody suggests to rewrite this, but we can approach whole transformations in a more robust and scalable way if we do this using one of these ideas.
Like I said, go to town. I'm not using peepholes, and maybe what I just heard you say was you can use peepholes in register allocation, and I did peephole-like things in the register allocator, sort of, but that was a much more fine-grained, low-level, like simple register swap register. That's not what we're talking about. The C2 peepholes work on an idealistic IR. That's the pre-machine code, right? It's an idealized. So the peepholes are themselves pretty damn trivial to read and write.
I don't think it really matters which representation you take. Like if you define the semantic of your intermediate representation and give it to this system which can derive the transfer.
Yeah, that's what I'm saying. That's what I heard Zen say. Take the C2, maybe I didn't hear right. Take the C2 semantics. It has a very strong semantics. Rewrite or come up with the machine readable version for this guy and see if he does a better job than the existing people rules. And my claim is I would be surprised if he did a substantially better job. I would think he might nitpick around the edges and get a little bit here and a little bit there, but nothing that you would see on any benchmark in any reasonable way.
Yeah, I believe
benchmarks. You could write a custom benchmark that says, if I don't discover this tiny fact, and I'm not talking about that.
I believe in you. That the thing is, there are like twofold meaning for that. The first one is discovering more opportunities in p-hole, right? The second one is it's about engineering efforts. So if we can define those rules one by one, let's say rule 1, rule 10, rule 1000, then it's easier to debug it. Why? Because if you run into some problem, you can use binary search to iterate, turn them on or off, and finally it takes you like 1 hour to pinpoint that, okay, this rule is buggy. This rule is buggy, then I can step in and figure out what's the problem, why this rule was buggy, right? But currently in C2, those rules scattered in different files. It's not very easy to name any of them. So we have to use pound if 0, pound end of pound and if. So kind of thing to
separate out what you're doing with what can be done.
Yes.
I don't claim that what your approach is what I would ever have done or did when I was doing it. I didn't have any trouble finding the rule that was busted and going after it. But I didn't do it by putting pound if defs around things.
Yeah, that's what I did. So maybe it was silly, but I feel that, in ideal situation, we can use binary search to pinpoint which rule was buggy, right?
So separately, okay, that's not what's going on in this paper here, by the way. Finding which rule is buggy, it has its own separate, there's an entire debugging strategy in C2 that has been in there forever that helps find these things. The main one is I added a new rule and something broke. Almost surely it's my new rule, right?
Yes.
That's the obvious one. And that's been true for 20 years. So you're in it adding a new rule, something breaks, I'm going to go look at the new rule. It's not a problem. So not finding the rule is not the issue. So what this guy's saying is we're going to discover that the preconditions were buggy. The rule was being inappropriately, an existing rule that has not triggered any other crashes has been inappropriately applied, and we can presumably come up with a test case that would validate that it's inappropriate. And wouldn't it be better if we didn't have to deal with it at all? And we would just automatically discover both the precondition and the execution strategy. And what I'm going to claim, and I've seen this kind of claim over and over again, is that the effort to get the tool correct such that it generically applies and finds all the exciting rules that you need to find for speed and performance and whatever is far exceeds the effort to hand roll the rules. Now, can we have a better support structure for the rules, including their preconditions? Absolutely. What happened in C2 is it incrementally built up as a people thing, and the people turned out to be very powerful and did all kinds of cool shit, and that was the major optimization. But it got incrementally built up for that infrastructure preceding it. So, looking back 20 years, I could do things differently. In particular, there's no gathering of everything I touched when I'm testing to see if this is the correct precondition. I don't have a list of everything I touched, so that if something else changes and the precondition either no longer holds or I should go revisit and reapply, I don't have that information around.
Kind of a cascading optimization of some sort.
Yeah, right. What I'm doing now with AA is I'm enforcing strongly that if a rule failed to apply and something changes and it now does apply, it got marked on the work list, and I'm deciding how much engineering infrastructure I want to have in place to automate that versus how much I just hand roll. And it's still way the hell easier to hand roll these things than it is to burn out a large heavyweight solver. The other thing is the same thing I did with the Berg pattern matching in C2 for the instruction selection. Was not worth it. It was an optimizing tool that totally picked the correct instructions, had all the cost benefit analysis trade-offs and yada yada, register things, everything else, not worth it. And the reason it was not worth it is because the layer of indirection between what you wanted to happen and what you could write was so great that you couldn't get simple trivial things to go through. Many things went through correctly, easily, but there would always be these cases where I needed to do something funny and that would not fit into the paradigm the tool supported. So I had to have a one-off. As soon as I had 10 one-offs, what the frick was the point of the tool, right? I kept getting one-offs and one-offs and one-offs, and the tool was just in the way because I had to step around it to get the one-off to go. So at that point, I said, everything's a one-off, kill the tool, and I picked up a few hundred more lines of code, and I lost 10,000 lines of 100,000 lines of a very complicated tool went away, and 10,000 lines of tool description went away, and I picked up 1,000 lines of C++ code that was easier to debug and manage. That was the decision back then, and it was applied to Berg in the wrong direction, and it applied, I think, correctly in the peephole direction. What I'm seeing you now is you're heading down that path. do a big optimized compiler where you automate, discover all the peoples. I'll tell you that you'll have so many exceptions to your rules that it's not worth it. But you have to burn yourself to find that out. And maybe the world's changed and I'm all full of shit, you know?
Wait, what do you mean of exceptions? So
I want to do a CAS instruction. Go write CAS in this people rule, right? It has to have all these weird atomic properties, has these fencing rules about ordering and reordering. It has these weird remodify right on the registers. And unless your people covers all these things, and that will be its own special piece of work, just to make CAS go, you might as well have done CAS as a one-off. So you do CAS as a one-off instead of trying to go hack. You bought somebody's SAT solver off the web, right? You went in the interweb. Give me your best SAT solver. It has the following language I describe things in. So I describe add, I subtract, multiply by 1, and plus 0. Oh, this is all great. Write CAS. Oh, I can't do CAS. What do I do? Okay, I have to have a one-off for CAS. So I write CAS as a one-off. Okay, I need to do call instructions, but call instructions are pretty trivial. But you do inline caching. Inline caching requires me to have patchable, self-modifying code with weird properties around cache line boundaries and NOPs that have padding that I can cache. And it's very strict in what I can do there. And it doesn't fit into this thing. So I have to have a one-off for inline caches. Okay, I have to do, and you start pulling out one-offs, one after another. I need my stack frame prologue. I have to find the return address at a fixed known location. So my stack prologue has to be wired a certain way, but I have to save a bunch of registers and restore a bunch of registers. I have a bunch of generic code to handle pushing and popping, but always the return address is in a fixed location that I've carefully recorded so that I can crawl my stack fast. And that all didn't fit in. So my prologue and epilogue code are a one-off, and on and on and on. You keep finding one-offs, and suddenly it wasn't worth it.
Okay. Yeah.
So I'm not saying don't. I'm saying go get your experience. If your experience is different than mine, come and tell me. But my belief right now is that you will fight an uphill fight for not much gain. But maybe I'm wrong.
Okay. Yeah. Let's see that. But the bottom line is, more automation is,
Yeah, I think more way C2 is written right now.
Yeah.
More automation would be helpful, but not this automation.
There's not this kind of super optimization thing.
Not somebody who's trying to discover the people rules and generate them. That I think is not the right automation.
Also keep in mind that over time we accumulate more and more of these rules, and now it's just an issue with maintaining this and making sure that things are correct. Like it doesn't scale well. That's the issue.
No, totally. It has scaled well for the last 25 years, and there are not giant more rules showing up. People's coding styles, like what happens with Scala, have mutated very slowly over 20 years, and Scala needs like better escape analysis, but that's not a people rule.
Wait,
I cannot say about C2, but like in LLVM, there's lots of stuff showing up, and like you would be surprised that people care about some things, but no, they find some like use cases where they need this kind of small transform.
For LLVM, it's already finding bugs. I mean, this automated verifier has already found many bugs in the deep holes for LLVM IR.
For LLVM, yeah. And
so encoding semantics paid off.
I'd be interested to see if it would be able to do the same thing for C2, but I'm thinking that because of the nature of the idealized IR.
Do they look similar or not?
I'm sorry?
If you open, I'm curious, if you open this last link, do they look similar to what you do on C2 level, or maybe it's a different level? Like
different level.
So this is for LLVM IR. And for example, you can have simple rewrites like right shift with -1 ended with another.
Yeah. So
is this the same layer?
I hear you. No, it's typically not.
Okay.
So I did a handful of things like the number 1 and xn -1 shift right because there's a couple benchmarks where people kind of were wanting it to happen. That's not what typically goes on in C2IR. These are bit twiddly transforms of which they would all be a one-liner to do the implementation of the people, like literally one line. The test for the naive structure would also be one line, but the complicated verification that the x and y and negative this, yada, yada, those tests would take us same code, and it'd be difficult as well. But that's not what C2 typically does. So maybe we're just talking a different language here. So I saw a multiply one. Yeah, multiply for shifting on what I don't know what an undef is though. We had a multiply signed unsigned over underflow thing we carefully screwed around with. Sign versus zero extension on, that's not one, and the number 43 mem copy is not one, but something similar. A lot of the range check analysis cases had to deal with under and overflow. If I say for I equals a to b, x sub I plus 2 billion is an array reference, but a and b are negative 2 billion and they wrapped, or they're positive 2 billion and they overflowed and wrapped and came back around to a positive number again, or whatever. We had to handle all those eventually. And so the range check analysis guy had more of this kind of thing, a handful, but then no more. Things like incorrect fabs with nan, we don't have nans in Java except the one, so you don't get this. Loop peeling is a separate thing, not a peephole. It's a major graph rewrite transform that's heavily tested for in other ways. I don't do icomp, sln, less than, whatever things there. That's done as unsigned and unsigned tests in C2. That happens all the time, by the way. It's just not an exciting transform. These are buggy ones. These are not all C2. Yeah. So what I don't know, what I don't see in here is the kinds of transformations that I suspect LLVM has that are also correct and also do the bulk of the heavy lifting. So in C2, peoples do like much of the heavy lifting, but they're also, sort of blatantly preconditioned test is easy and it's correct and was been correct for 20 years and we're done. Things that do f add of non-zero op plus 0, not in there and not exciting to anyone. And maybe it hasn't been yet, and maybe they could be, and in which case, you get more excited here. But these are like a different set. The error ones, at least, are all different than things that C2ers are doing.
Well, and there is a difference between correct from the standpoint of the engineer who implemented it and created a test, and then correct as proven by some automatic solver.
No, I'm claiming correctness by, basically by 25 years of execution time. All bugs, as someone else already pointed out in this call, all bugs become obvious when a billion people use it. Not saying formally proven correct. That's interesting. Typically, you find something, usually not in anything that was dead already.
But then if I'm writing a new compiler and my choice is either to prove it using automatic solver or wait 25 years to find all the bugs, I'll probably take the solver if I have the option.
Yeah, see, but I would claim if you reach for a solver and then you discover that your system is slow and it takes forever to add things and you can't get engineers to work on it, that maybe that wasn't necessarily the best answer. If a solver sits on the backside and helps validate testing, maybe it's interesting. I don't have the infrastructure in C2 and actually in AA either to peel out the precondition so easily because it's optimized into the implementation and application of peoples. So teasing out the precondition would be a piece of engineering work that would be difficult, with the only goal being that I could then abstractly define the precondition, hand it off to an external tool and test. That might be useful, it might not. It won't make my execution time go any faster, my compilation time go faster, and it probably won't help me generate code any faster because all the obvious bugs got found by what I did already, and all the unobvious bugs were relatively rare. When I go to a billion people, I want that. When I'm me and 10 other people, I don't care. So yeah, go for it. If you do it from the start, maybe. I don't know. I claim it looks like a lot of trouble for not much gain, but maybe if I thought it could find all the things without me telling it, I wouldn't have been here. But I don't think your SAT solver would work here either. In my case, the people rules also do the typing. And I don't know what a SAT solver is going to do with that. I have to do all transformations to a monotonically improving type. Typically no change, but it can be a monotonically improving. And that is part of the precondition. If I were to roll backwards on the types for doing a transformation, yeah, that is illegal. And that is a different subtle beast.
Oh, but this is something you can also try to express for some kind of solver and then verify by proving.
The way I would express it would be to grab the perimeter of the rewrite rule and claim that when I'm done, those types all monotonically improved. Recomputing those types is all monotonically, but that has nothing to do with the SAT solver, and it can be done in a simple, for a list of nodes, did your type improve?
You mean just assert in compile time?
I'm sorry?
Do you mean assert in compile time?
Yeah.
Okay.
Yeah, it's an assert. Like I said, I don't need these things when I'm doing and applying to people, because you do your simple correctness check, which you think is the minimal one that says, I think I have the right precondition, I'm going to do it. But you know there's a broader precondition. Like on debugging C2, AA right now, one of my big asserts is, after every minor people of application, I revisit every type in the entire program and confirm that it monotonically improved. That is really slow. So I don't do it all the time. But I have effectively, it's not a prover that it can't ever happen, but it is proof that it has never happened so far.
Then you have a customized solver, It's not like SMT solver, but it sounds like you prove that your program, your optimization is monotonically better and better.
Yes. So the types, I have a solid theory that says they are only monotonically improving. That one is totally like wired in. The people optimizations, I want to have what's called the one-step Church-Rosser property. I know I don't have it. I know how to get to it. When I have a one-step Church-Rosser property, I will then have a strong proof that, in fact, it's monotonically improving. Okay. The people rules as applied by LLVM, even if a SAT solver finds them, will not give you the one-step Church-Rosser property. So there will be, it should be, as I say, there could be a piece of code for which, despite having a SAT solver go to town, it did a suboptimal thing because it applied to peoples in a poor order and lost an opportunity that was much higher value. To not lose an opportunity because you did a valid transform requires you to have a one-step Church-Rosser property, which is it doesn't matter what order you apply any of the transforms anywhere, you get it. And this is what the lambda calculus has for their proof that the lambda calculus derives to an answer. So to get the same kind of thing out of a typing system, I need to have the one-step Church-Rosser as part of the people. So that also turns into, there is one code shape that comes out of at least the high-level IR. There's one exactly and only code shape for any given program. And it's not the one that you got from, it happened to be, it'll be apply the transformations in any random order with a die roll, as Cameron was saying, apply a die roll every time. And I, in fact, do that die roll. Do I get the same answer out? That's a more difficult thing, has nothing to do with SAT solvers. It has to do with the property of the peoples themselves. All possible directional changes that I can arrive. If I taking some peoples, I have a graph shape and I mutate a new graph shape and a new graph shape and a new graph shape. And I started the same graph shape and I applied a different people and I got a new graph shape, a new graph shape, a new graph shape. They have to all eventually come to the same graph shape in the end, or else one was better than the other. But all the peoples were independently provably correct, and all possible peoples were available to you. But if you don't get to the same spot in the end, there was an order of application that was better. It had nothing to do with SAT solver or peoples per se. It had to do with the continuous application of all peoples not having this one-step Church-Rosser property.
And also in the last step of optimization, there's like a reshape, graph reshape phase. So I feel that
graph reshape in C2 happens all the time. It's not in the last. Every step there's graph reshape.
No, I mean there's a dedicated phase called graph reshape. So there's some kind of sanity check right before code gen. So make sure that your graph is still valid. Otherwise, probably you cannot guarantee get like a meaningful code if the input of graph is broken or something like a broken shape.
Broken graph, things are broken downhill, garbage in, garbage out, you die. Sometimes
yes, but
yeah,
I do carefully read this reshape phase, but still I feel that there's we miss like a solid definition of legal or valid graph.
Hang on. Which one? Because I was just looking at. Wait, so you're missing a solid definition of what?
Legal graph. What's the definition of legal graph?
Wait. Yeah, I know what a solid legal definition of a graph is, the C2 graph to this day. However, that doesn't mean you had a valid semantic transformation from bytecodes to C2 graph. You could have made a valid C2 graph that was totally busted. For instance, I could take a quicksort algorithm as an input IR and produce a C2 IR that returns 42. Throws away everything, returns 42. That would be a valid C2 graph, but not a valid transformation from the bytecodes. Right? So you can write broken graph rewrite rules that break the graph in very subtle ways that then allow other transformations to happen that are busted, and you get more and more busted over time. Usually, like I said, this is one of the cascading fails and the graph dissolves away and you end up with the empty program. Having applied 1,000 delete code optimizations in a row because the program was busted, you have an empty program and you're dead. You were mentioning a phase about rewriting. What was it called? Do you remember the name? I'm looking at the C2 code right now. That's okay. All right. We're like 2 hours in. I have other things to do today. In particular, I have to go deal with my taxes. Let's call it. If you want to talk C2 and graph peepholes, let's do it again. If you want to talk about, here you threw out compile CPP line 2300. I'll look quickly, but I'm gonna call it because we're getting way on here. Yeah, what's the name here? You got a name of the function? Because I'm on a JDK 7 code. I don't have a whatever version of code you're on. Final graph reshaping walk. That's probably what you meant. Yeah. This is just like it does some things that I've postponed for a long time. Like the C2 IR, yeah, this guy. Yeah, I'm at the right place now. What was your question about him? What is the semantics? This is get the impl version of things, but I think we're in the same boat here. Yeah. What this does nothing exciting. It does some things like C2 does normalization in a large, strong way to cut down the number of rules you need. Those normalizations push constants to one side of commutative operations, typically addressing math. They're shoved around a different way for x86 to encourage x86 update in place operations. That's one of the things. Decide FP or not. Ooh, yeah, that's cool. Okay, fine, Matt, that was a good one. Yeah, detecting infinite loops.
Next week, Matt. Next week.
Next week. Okay, yeah, I'm with you. Fine. Okay.
No, I'm saying the tax one.
Oh, the tax one. Yeah, it's coming
Debugging the tax compiler will be next week.
Yeah, it's new. I can't go talk to my tax attorney. I have to prepare my papers ahead of time and drop them off and have a Zoom call in a week. Which is probably really convenient for them because they don't have to do it in the hour while I'm in their office and billing them by the hour. They can do it offline, and then they tell me, Cliff, you forgot XYZ. Like, oh, okay, fine. I would love to see a SAT solver do something on a core optimizer sensible, and I think we're a long ways from that. But if you can prove me wrong, please God do so.
Well, it's a long way, but we should start at some point if we want to get there.
You know, somebody has to do it first, right? I see a lot of academic papers, and many of them don't count. I've stared at academic papers claiming the end of the universe for compilers for 30 years, 40 years, and it hadn't happened yet. So I'm not holding my breath till I see, like, C2 came out and changed what people thought about compilers. Until that time, I face the big uphill battle that I'm giving Zen right now. You can't make a static ahead of time compiler optimized fast as a JIT or whatever, you know, it can't be done. And I fought the uphill fight. So now it's Zen's turn.
Goes in.
Good luck. All right. Next week. Bye-bye.